ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಸೊ ಕಳೆದ ವಿಡಿಯೋದಲ್ಲಿ ಗ್ರಾಫ್ ಕಲರಿಂಗ್ ಬಗ್ಗೆ ಎಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಒನ್ ಆಫ್ ದ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ಗ್ರಾಫ್ ಕಲರಿಂಗ್ ಅಂತ ಡಿಸ್ಕಸ್ ಮಾಡೋಕೆ ಹೋಗ್ತಾ ಇದ್ದೀವಿ. ದಟ್ ಈಸ್ ಹೌ ದ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಗ್ರಾಫ್ ಕಲರಿಂಗ್ ಈಸ್ ಯೂಸ್ಡ್ ಇನ್ GSM mobile networks. So before going to explain the application, so first we need to discuss one important conjecture in graph theory, that is four color conjecture. Conjecture antandre that is the result that was proposed by someone which is not yet proved. ಸೊ ಅವ್ರ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಷ್ಟು ಹೇಳಿರ್ತಾರೆ, ಇನ್ನು ಅದು ಕರೆಕ್ಟು ಅಥವಾ ರಾಂಗ್ ಅಂತ ಅಂದ್ಬಿಟ್ಟು ಪ್ರೂವ್ ಆಗಿರಲ್ಲ. ಸೊ ಸಚ್ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ವಿತೌಟ್ ಪ್ರೂಫ್ ಆರ್ ಕಾಲ್ಡ್ conjectures. So there is one famous conjecture in graph coloring, that is called four color conjecture. This says that any map on the plane can be colored with, properly colored, you can say properly colored with four colors, or you can say at least four colors. So equivalent form of this statement, we can say that the map on the surface of a sphere can be colored with only four colors, so that no two adjacent countries have the same color. You can draw, I can map the countries on the sphere with four different colors. That coloring will be proper in the sense that no two adjacent countries will receive same color. For example, let us see here how the map of India can be colored with four colors. So this one here, the map of our India is mapped with only four colors, 1, 2, 3 and 4 colors, such that no two states which are adjacent should receive same color. So the map of India is colored with four colors exactly. Similarly, we can map all the countries in the globe with only four colors, so that no two adjacent country should receive same color. That is the result that was proposed by A.F. Mobius. This was proposed by Mobius during 1840, but still no one has proved this result, and no one has given counter example to prove or to disprove this result. So this is still remained as conjecture. No proof is obtained till today. Now using this concept of four color conjecture, the mobile network, GSM mobile network is going to work. How this result is applied in GSM networks, that we can discuss in next moments. Now let us general communication networks. So next part of our discussion is general communication networks. General communication networks. To model this general communication network, we use directed graphs. See, whatever we have discussed in our previous video, that is all about undirected graphs. That means you will be having two vertices, and then there will be an edge between these two vertices. There is no direction to these edges. If you assign a direction, then it will be a directed graph. So any graph with directed edges or edges given direction is called a directed graph. It's called a directed graph. So whatever we have considered till today is undirected graphs. Starting allಷ್ಟೇ discuss ಮಾಡಿದ್ವಿ directed graph ಅಂತಂದ್ರೆ ಏನು ಅಂತ. So only in that part we discussed directed graphs. After that we considered only undirected graphs. See, when we write an edge like this, we'll assign or we label this with some weights. So suppose I'll write 10 here. So that is the weight given to this edge, directed edge. So how the communication network can be modeled with directed graphs? If you see that, we'll have directed graphs represents communication networks where the directed edge, the edge are written like this here. Directed edge represents the channel. This directed edge represents the channel, and weight given to that directed edge represents capacity of that channel. For example, you may consider the gas lines, gas pipes and then ಬರುತ್ತಲ್ಲ. So gas pipes. So this may be modeled with directed graphs. Telephone lines, this can also be modeled with directed graphs, and roads can be modeled with directed graphs. This directed edge represents the channel. So gas pipe, suppose you have 3 homes here, will give connection like this, say. Suppose these 3 homes are connected in this sense. The line, this is the starting point of the gas pipe. So then this is connected to this one, then this connected to this one. So this is a directed edge. Gas flows from this to this end. So this is the directed edge or a gas pipeline in real words. Then you have connection from this to this. How much gas is going to carried through this pipe, that will be the weight of this. It may be in gallons or maybe other units used to measure that capacity. So whatever we label this edge, that will be the capacity of that edge or that communication network in general. So similarly, roads, you may have many number of cities and roads connecting that cities. There will be some particular restriction to these roads, or you can take bridges. See, only that prescribed number of vehicles can pass through these roads for some particular time. ನಂಬರ್ ಏನಿರುತ್ತೆ ಅದನ್ನು ಮಿತಿ ಮೀರಿದ್ರೆ ಬೇಗ ರೋಡ್ ಹಾಳಾಗ್ಬಿಡುತ್ತೆ. ಸೊ ಪ್ರತಿ ರೋಡ್ಗೂ ಕೂಡ ಅದರದ್ದೇ ಆದ ಲಿಮಿಟ್ ಇರುತ್ತೆ. ಈ ರೋಡಲ್ಲಿ ಇಷ್ಟೇ ವೆಹಿಕಲ್ಸ್ ಓಡಾಡಬೇಕು ಅಂತ. ದೆರ್ ವಿಲ್ ಬಿ ಎ ಲಿಮಿಟ್ ಟು ಈಚ್ ಬ್ರಿಡ್ಜ್, ಈಚ್ ರೋಡ್. ಸೊ ದ್ಯಾಟ್ ಲಿಮಿಟ್ ಆರ್ ದ್ಯಾಟ್ ನಂಬರ್ ವಿಲ್ ಬಿ ಲೇಬಲ್ಡ್ ಹಿಯರ್. ಸೊ you may have this road may have the limit 25k. So per day only 25,000 vehicles can pass through that road, or this may have less limit. This it may have 20k. Suppose there may be an edge here. Now this may have there may be a bridge that may have limit only 5 ton. No vehicle having more than 5 ton load should pass through that bridge. No vehicle with more than 5 ton weight should pass through that bridge. So similarly, in many ways we may use directed edges to model communication networks. Next, how GSM network uses graph coloring. Our actual problem we are going to consider here. GSM networks and graph coloring. See, GSM network, this was created in 1982. It was created in 1892 to provide standard for mobile phone system. First GSM network was launched in 1991. Though it was created in 1982, the first GSM network was launched in 1991 in Finland. So today GSM network is the most popular and is used by over 2 billion people across more than 212 countries. See, more than 2 billion peoples are using these GSM networks over more than 212 countries. So this is the importance of GSM networks, we can say. Now, how graph coloring is used in GSM networks? As I said already, the 4-color conjecture is used in GSM networks to establish the network over the given region. See, suppose there is a telecom provider who wish to provide its service in a particular region. First they will identify the region, then they will divide that region into hexagonal shape, that we call as cells. See, that we can explain here. See, they have to identify the region where they have to provide GSM service or GSM networks. They will divide that region in hexagonal regions, into hexagonal regions. So this is the way. See, like this they have to divide the whole region into hexagonal shape. Then they have to place the network towers here. These regions, see these small regions, so totally there will be 16 regions. So these regions are called cells. So these are called cells. These are called cells. Each cell should have a communication tower. So this one is the communication tower. See, this will be a communication tower. So first they have to identify the region, then it will be divided into an hexagonal. Then each region in that shape is called cell. Each cell should have a communication tower that connects with mobile phones within the cell. See, this network is connected to the mobile phones that appears within this region. So here are mobile phones that will be connected to this network or that tower. Mobile phone connected to GSM network by searching for cells. See, whatever the mobile phones we have within this region, that should connect to the tower within that cell by searching for that cells in the immediate vicinity. So whatever the mobile phone that comes within this region, that has to search for the mobile tower within its region. So that has to connect it. See, this is the mobile tower with that is nearby to this. This mobile should connect to this network. Similarly, whatever the mobile phone in this region should connect to this. If you come to somewhere here, so the mobile phones within that region, or you can say within that cell, should connect to that mobile tower. GSM networks operate in only 4 different frequency ranges. So this is where exactly graph coloring concept is used. So we have the region, we have divided that into 16 regions, 16 sub-regions which are called cells. Then we have placed mobile networks or mobile towers in each cell. And additionally we said that a mobile phone within that cell should search for the tower within that vicinity and should connect to that. Now how the frequency is divided into that towers, that is very important. So GSM network operate in only 4 different frequency ranges. How this number 4 is fixed? That is due to 4 coloring theorem or 4 coloring conjecture. Why this should happen? Because the map of the cellular region can be properly colored with 4 different colors. So since by 4 coloring theorem, the map of this region can be colored with only 4 colors. So suppose you have 1 2 3 4 colors, such that no 2 adjacent regions or adjacent cells should have same color. Then all the cells here that is mapped with first color that will be given with frequency range f1, that will be having common frequency range f1. The cells having color 2 are mapped with second color will be having second frequency range. Cells having color 3 will be having third frequency range. Cells having fourth region will be having fourth frequency range. By 4 coloring theorem, whole region can be colored with 4 colors, properly colored with 4 colors, so that using that, assigning a frequency to each color will get at most 4 frequency ranges to cover this whole region. That's where exactly the 4 coloring theorem or graph coloring concept is used in GSM networks. So that's what we say, regions with same color has to share same frequency. So then as usual, the GSM networks is going to provide the service to the common man's or mobile phones. So what are the services that are given by GSM networks? That is listed here. So the main thing is how the graph coloring is used in GSM networks. So once again I will repeat it. The region to which they have to provide the service, they have to first identify it, then divide that into 16 sub-regions which are called cells. Each cell they have to place a mobile tower, so that the mobile phone that comes within that region or within that cell has to connect with corresponding mobile tower. Since that region can be mapped with exactly 4 colors as an application of 4 coloring conjecture, we can assign only 4 frequency ranges to all that region, so that the frequency range will be distributed properly to all the networks. This is where the concept of graph coloring exactly used in GSM networks. What are the services provided by the GSM networks? That is an additional point that is listed here. Now let us see an example. How the service mobile service is provided in India by using this concept. Here we have the map of our India. As I said already, India is mapped with only or colored with only 4 colors as an application of 4 color theorem. Now we need to provide GSM mobile service to this whole country. Then we have to write the corresponding graph of this map. So corresponding graph of this map is called dual graph of the map. How should we write that map? That can be done. See, each state will act as a vertex. Each state will act as a vertex. So here this will be a vertex and this will be a vertex. and this will be a vertex. Now edges will be drawn if the corresponding states are adjacent or they are sharing common boundary. So these two will be adjacent, and these two will be adjacent, and these two will be adjacent. Similarly, you have to consider all the states and then draw the dual graph of that graph. So the dual graph of India will be like this. Again, yes, here these are sharing common boundary, and then if you draw a few more vertices, you get this one. So this is the dual graph of India graph. Then considering this dual graph, you have to identify suitable region in each of that. Then see, here also we have just 4 colors to color this graph properly. Then you have to identify the region, then distribute the frequency as per the color. So this is how the graph coloring concept is used in GSM networks. So this will be very much important application of graph coloring. So with this we have discussed 2 applications of graph coloring. One is time scheduling, how to schedule a timetable for teachers and corresponding subjects as an input, and the second application is GSM networks GSM networks using graph coloring. So with this the applications of graph coloring we are going to wind up. Next we shall discuss some electrical networks. Thank you, and this research paper will be shared to you for your reference.